Okay, and so today what we're going to do is focus on diversity. So utilities are an enormously diverse range of organizations. Good old Wikipedia defines a utility as an organization that maintains the infrastructure for a public service. So that seems to cover a lot of ground, really. From our webinar sign up, most of attendees today seem to be FME users already, or at least familiar with FME in some way. So we're not going to spend very much time today introducing FME. Trent is going to do a little demo later on, just in case you haven't seen FME before. If you're working in the utility space, maybe hands up if you are on the webinar interface, if you can do that. If you're working in that space, then you're probably working in a relatively narrow area of your organization. Usually, if you're working with FME, it'll be in the GIS team, but the roles in a utility are as diverse as the number of types of utilities themselves. So people in your organization will be working in anything from GIS to engineering, land-based management, risk or emergency management, and of course many more tasks. So what we'd like to show you today is the diversity of uses of FME that FME has been put to in the utility space. Our main goal for today, I suppose, is to encourage you to look at other data problems you or your colleagues might have in your organization and hopefully get more value out of the investment you have made in your FME licenses and your FME training and learning FME as a toolkit, and then you can push those boundaries forward a little bit. We've had many great customer presentations on FME working with utilities data. These have been presented in the World Tours events that we do, our user conferences, some of these webinars. And so today what our plan is to give a best of montage of some of these presentations and just to show the diversity of uses of FME in a very broad brush way in this very diverse business vertical called utilities. Hopefully giving you some ideas on how you might be able to expand your use of FME in your organization, maximize the value of your existing FME licenses. You might also see how you might be able to break down some of your internal data barriers or stovepipes and make better use of the data you've got across the different stovepipes in your organization. In the summaries that we've got, we've included links so that you can chase down the original presentation if you're interested in more details on that. So utilities, an organization that maintains the infrastructure for a public service, usually with some form of public oversight or regulation. Of course, that does include municipalities because they pretty well always incorporate utility, particularly around water and wastewater. Often municipalities also have some form of electric distribution. So that's kind of a summary there of people in utilities. Trent, you were going to run us a poll?
Yes, we're going to just see where exactly, we're just going to ask you where exactly, which utility do you work with?
And so if you can give us an idea of where you're working, yeah, if there's an other there, that would be good. While we're doing that, I'll just mention that within a utility, there are a wide range of tasks where quality data is vital for basically accurate decision making. So whether it's in an electric utility, importing SIM-XML into your engineering systems like SCADA or ADMS, or doing hydrological modeling for flow direction water utilities, all that data needs to be of good quality. Let's go back to your poll there, Trent, and see what...
I think we just showed it. Yep, there we go. So it looks like electric is the big one as normal.
Oh, okay. Telecom's dragging their feet. What's oh yeah, so some people can let us know in the chat if they're in the other space. Yeah, good. There's also diversity in tasks and formats within the diverse utilities that we work with. So this is a typical list of kind of some of the formats that we bump into in utilities and some of the areas that people work on within that utility space. But before we sort of jump into looking at some of these past presentations, Trent's going to give us a little FME demo on a classic use case for FME.
Yes, I am. Now, a common theme for utilities is fixing issues that occur within your networks. This could be replacing a transformer, fixing a gas valve, or fixing a water main break or a leak, for example. Now, before the issue can be fixed, it first needs to be reported, followed by some information gathering needs to occur in order to determine the extent and severity of the issue that has been reported. Now, carrying on with that water main break as an example, let's say a call is entered into our 311 reporting database that is reporting a water main break. Now, before any work can be done, we need to know a few things. Where did the break occur? How many addresses or properties are affected? As well as the number of properties at each residence that are affected. The time the break occurred if possible, because we want to know if people are without water, how long have they been without water? And then as well as, the closest valve to the break. Now this is required in order to assist the technician to determine which valve do they need to shut off prior to fixing the break. Now if we dive right into the workspace here, I'm going to maximize this for everyone. So we look here at this first bookmark here. So this is our source data. So this is where we're pulling in those 311 reports that have been reported as water main breaks or any type of issue with a utility. And then we're also pulling in our water network data. So here you'll see we have control valves, we have our water mains, and then we also have our network junctions that are connecting the two. Now, right away, we want to do some network prep in terms of basically just ensuring that everything is connected correctly, as well as just making sure that everything is in the right spot and everything. So we have, or like a reprojector, for example, just making sure that the two data sets are aligned correctly. From there, we're gonna basically kind of blow up our original water network in terms of we want to basically create a new valve separated network. And what this is going to allow us to do is basically focus on the individual, focus on the water network as almost by a valve by valve basis, because we do not need to worry about the entire water network for this case. Now from there, once we have our valve separated network created, we're basically going to try to get a list of control valves that would need to be turned off in order for work to take place. Now, why this is important is basically we want to know which valves are directly related or spatially to the problem report that has been established or that has been reported. Once we know this, we can gather the remaining information that we require, such as the number of properties. Now, here is just kind of touching on what I mentioned earlier. So we don't want our entire water network data written out to a report for the technician. We just want the little area of interest that we're focusing on around that break. So here we're just creating a very simple bounding box, essentially, to reduce the scope of the data that we are working with. Now, land parcels. Now we're going to pull in some additional information, basically to try to gain a more complete understanding and provide the technician with as much information as possible in order to address the break. So here we're pulling in land parcel information. Now this is going to allow us to keep track of the addresses that would potentially be affected by work, as well as determine the number of residences at each address. For example, we might have one address that's an apartment complex where up to 30 different residences might reside there, in which case we can't just shut off the water without them knowing. Now, next, we're going to bring in some background imagery. So this is basically just to provide the technician with some locational context, a quick, basically, orthographic image on the report, just to give them a rough idea of exactly what is the where the break was reported. What exactly does the surrounding area look like? Is it in the middle of an intersection? Is it residential? Is it downtown? Just to provide them with a more complete picture of the problem. And then lastly, we're just going to pull in or just reduce, add and reduce the water network information further. So basically, we're just going to pull in and make sure that we're actually maintaining the potentially affected water mains and any junctions that are surrounding the break. And from there, we're going to write out to an Excel sheet that could then be could be passed or delivered to a technician to go out and actually do the field work. So just in that last bookmark here, it's just basically just a sheet inside an Excel. So I've got a number of sheets, and we're using a template for this. And basically all the template is doing is it has a couple of formulas within it that is going to pull the data from the different sheets and just combine it into a single report for us. Let's give this a quick run.
Trent, while that's chugging away, someone's asked us, do we use connectivity data? So I guess the answer is yes, in a way. We don't really have a full network tracing tool in FME, but I think somewhere in your workspace you've got the topology builder, which is essentially building the network. Is that fair to say?
I believe so, yes.
Yeah.
Or we might not be using the topology builder. I think we're in this case, actually, we have a network topology calculator that is doing that, but we also use the point online overlayer, which could be used kind of in place of the topology builder.
Yeah, so we're building the kind of the local network, finding what's connected there, and then using that in the report.
Correct. So we see this ran correctly. Now, if I open my report, here we have it here. So this is our completed report. You'll see right away we have the incident type, so that was reported, as well as the area, the location, in this case, an intersection, and then when it was reported. We also have the number of addresses or the list of affected addresses, as well as the number of unique sites at each address. You know, just highlighting this 777 Hornby Street, where it looks like it must be an apartment complex or maybe condos where there's 7 unique addresses or residences at this single address. As well as we have that orthographic image that I touched on, basically just providing the technician with a some photographic context of the issue of where it was reported. So here we can see it looks like the middle of an intersection in downtown. We see we've got a few complexes here and then maybe a little park. So that's, you know, a pretty simple kind of workspace there, probably touching on a pretty basic task that occurs on a day-to-day or week-to-week basis. Now, if you wanted to take this one step further in terms of automating it so that basically if a report were to come in, that this report is generated automatically, you could upload this to FME server and have it basically triggered on each new report being entered into the database. Now, to carry on with that asset management kind of focus that we just looked at there, now an important process of any utility is the managing of assets. This ranges from design through to maintenance. Each utility has their own set of standards or regulations, and as a direct result, have their own unique tasks. FME aims to help with the monotony of the data handling and analysis that comes with the management of everyday tasks. With FME, you are able to gain value and understanding by combining your asset information with other systems, such as your traditional GIS, in a single environment. Not only will this help reduce the traditional data silo architecture that most industries face, but has the added bonus of letting you integrate with additional systems to provide a more complete understanding of the system process. Now, by combining asset management with traditional GIS, utilities can gather tremendous insight into their utility architecture. Now, just a quick plug on that, you know, asset management, FME kind of integration. For both Maximo and CityWorks, FME has web connections on FME Hub. Now, for CityWorks, we also have some custom transformers on the hub that allow you to interact with the CityWorks API or the REST API. These use that web connection I just mentioned to authenticate each call. Now, really, they're just wrappers around an HTTP caller, but they take away that side for you. So you just have to worry about the actual, what you'd like to accomplish in the workflow. Now, no custom transformers are available yet for Maximo.
But coming,
Yes,
one
coming.
of our colleagues, Dave, is looking at that right now.
Now, no customer transformers for Maximo quite yet, but as Mark just touched on, they are coming. They're in the works as we speak. Actually, you know what? After this, we'll go check on him, see if he's done yet.
Yeah, right.
Now, if you want to take this one step further in terms of, allow for automation, there's webhook capabilities within CityWorks that allow FME Server to respond to events in CityWorks. So this offers an even tighter integration where people can basically have a job run in response to changes in CityWorks. And maybe that job even hits the CityWorks API or one of their other systems. Just basically having a complete integration. Now, just a quick example touching on that before we dive into a more in-depth one is FME can help with organizing of any data and making it easily accessible to either stakeholders or the public. Now, this was the case for the city of Nanaimo, who was able to spatialize the city's sanitary and storm pipe video inspections. Now, using FME, they were able to apply video inspection data from an Access database and join it with their GIS. This allowed the GIS data along with the video recording to be accessible in a single place for the city's internal mapping platform. This removes that data silo problem that I mentioned earlier and makes the inspections available to all departments within the city. It basically, it just maximizes the investment in that inspection process of not being a one and done. Now looking at the next slide. So this is from the New Mexico Gas Company. Now they were using FME and FME Server to integrate data from various databases to visualize and feed web maps, as well as report emergency outage processes and drive their mobile web applications and their geospatial data analysis. Now, their original process involved mapping data from their compliance database to fit into their GIS database. Now, the new process that they developed basically removed a lot of the manual processing that they had to do, or the manual entry. Basically, the new process would have a work order being created. Now, as I just mentioned, originally all the data would need to be entered at each stage of their process. This is no longer the case, as any required work order data that was initially entered will be carried through the remaining processes. From here, the construction phase would take place. This is the installation of the pipes, along with as-built locations being digitally collected with GPS and barcode scanning. This allows the utility to ensure that pipe information is accurately collected. Now, once the construction phase was finished, or is finished, the data is moved through the GIS from staging to production. Now, any compliance data will be pushed into the correct compliance database. And as mentioned, the work order that was originally entered is tied to the data throughout the entire process. By changing their process, the city of Nanaimo, or the New Mexico Gas Company, they were able to gain value from their workflows. This allowed them the option to better locate pipe and maintain pipe details for individual pipes. Now, this greatly reduced the error of manual data entry by auto-populating pre-existing field information. It also reduced data entry times by being able to carry forth required data through the whole process across various systems, as opposed to being being required at each step manually. Now, we have looked at asset management. Let's look at a different kind of management, risk and emergency. Over to you, Mark.
Thanks a lot. Maybe just before I go on, I'll point out that we are butchering all these presentations and summarizing them. So there's a tiny URL, FMELY, on each of these slides, and you will be getting a follow-up email from this webinar with a link to these slides, so you'll be able to track down any of these presentations if you any of them seem interesting and you want to dig a bit deeper. So yeah, let's look at emergency and risk management. It's an important task in any utility. The idea being to try and mitigate the external factors that could degrade the overall health of the service that you're providing. It can include, but obviously not limited to, risk assessment, weather predictions is a big one, disaster preparedness. Risk assessment usually aims to anticipate the effects on a utility of a given emergency event, such as flooding, tornadoes or cyclones, wildfires, and obviously those kind of events will depend on your service area. You might also have regulations in effect that require risk assessment. And Matt Landry from Access Midstream presented an example on gas pipelines in urban areas at one of our events. Here they were producing maps of where gas facilities were located in high-risk areas, and this is his formulation here. Risk of failure is the probability of failure times the consequence of failure, and that's his matrix that he uses there to try and score high-risk areas. So that was kind of an interesting presentation to try and sort of measure the level of risk for their gas facilities. Emergency management is often aimed at supporting operational services during high-risk events. An example from one of our local utilities here in BC, Fortis, designed a system based on FME and also in conjunction with the small geospatial analyst. And so that's often a combination using FME with some other tool set. That's fine by us. And so they were able to automate the assessment of risk to their infrastructure from wildfires across the province, feeding from the BC Wildfire Service and getting that data and incorporating it into their network data. So that was pretty interesting as well. But around this area of emergency management, the presentation I'd kind of like to focus on is one by Aaron Ambler at Powerlink in Queensland, Australia. So they've done some really excellent work on risk and emergency management on their network. Prior to 2010, Powerlink had no internal emergency data or information support, and so they began introducing systems in 2011 with the beginnings of a fully automated data download supported by FME server in 2013. So they've been using our stuff for quite a while. 2015 was when they broadened this with a bit more development in FME for mapping automation. And now they have a fully automated data-driven approach to emergency awareness that covers bushfires, cyclone damage prediction, and flooding. And their system pretty well and operates entirely within the FME environment with their key kind of data that they need for this process stored in Oracle. And all kind of automated using FME server. So here's one of the examples of one of the Powerlink workflows that they've put together in their cyclone impact awareness. So the first step is an early warning. And so that comes from the Joint Typhoon Warning Center in the Fiji area. That's where most of their cyclone events kind of originate. So that's triggers some kind of processes. And then as that cyclone moves across into the Australia region, their Bureau of Meteorology starts tracking that, and the data supplied to them by the BOM triggers some early warnings in the Australian waters. And then cyclone preparedness, so they start building maps of where the cyclone's likely to go. And so when the cyclone actually enters the Powerlink kind of cyclone warning area, they trigger some warnings within their system. And then they actually start monitoring the cyclone in detail, watch and where the warning areas are present. And then they start to do some predictive work, and that's what some of their operators really requested. So that's an analysis of the wind areas, and so those wind areas it's kind of defined as very destructive, which sounds scary, very destructive, destructive, and damaging. And it looks at predicting the wind areas' impact on the network that they have based on design wind ratings for different facilities that they have. It also assists in timing of impacts at different locations across the network so that they can prepare their crews as well. So then they have the actual active impact. So this is when the cyclone actually hits and things start to get a little bit hairy, and so that's when the crews are notified. And then post-event is when they start looking at the impact itself, looking at the damage reports, figuring out where to send the crews. They also continue to track the cyclone as it becomes a tropical low. just looking for potential flood damage rather than wind damage now. And so, as you can see, it's a very sophisticated, interrelated workflow. All the tasks are based on FME. And so, because it's kind of a very critical system within their whole emergency management, what they've also built is a whole fault notification process that keeps track of FME running and their FME server. And if a fault is detected in one of their workflows, they can send, or one of their systems, they can send text and emails to on-call personnel when a system error occurs to make sure that system, the whole system is up and running, and so that when an event does occur, they're all ready to track it. And if you look at the presentation, you'll see that there's some great map products that they produce out of the system that they deliver to the different operations people as they need them. And so that's a quick summary of that quite sophisticated presentation. So Trent, I think you're going to start to look at FME in design and planning.
That is correct. Now, just trying to see how to start. Basically, one area you might not be super familiar with that FME can work with is design and planning stage of a project. With data silos still being a real issue, the need for delivering and receiving critical information from the design group is an important process of any utility. Now, being able to automate this delivery or receiving of data is even more important. No individual wants to wait for a manual process when it can be automated. An example could be providing the design team with current network information in the format or model that their system requires. Now, in the design process, an important component is the QA or validation of a workflow. This can be implemented directly into the workflow you are developing with FME. More on this later. Now, BPG Designs is a telco design and construction company. Now, through the use of FME, they have improved their fiber design and permitting workflow process, reducing a workflow from 10 to 12 steps to approximately 1 to 2, resulting in time savings of about 2/3 of the original process, or 60%. In addition, the new workflows give repeatable and consistent results because they are automated with FME Server. Now, BPG needed to produce consistent design results from differing inputs that would comply with each client's different geodatabase schema. The process had to ensure that generated design data would pass submission validations and aim to produce a geodatabase within 2 days of a permit being issued. Now, the source data sets they were working with were primarily DWG, but it was uncertain as to what features or layers would be present in each DWG. The schema could be altered during the life cycle of a project, and as such, the data submitted had to be validated against expected values. This included ensuring duplicate IDs were never assigned. Now, originally, this process was manual, which, as you can imagine, was just not scalable. By implementing FME, the workflow process allowed for flexibility and scaling. They were able to perform validation on the data and automate corrections on data that failed validation. This in turn allowed BPG Designs to produce an error report with errors that could not be corrected automatically. Overall, this cut down process time from 10 to 12 steps to 1 to 2, while also cutting the time by, as I said, by 60%. Now, as I touched on at the beginning, data quality and validation is an important aspect. We're going to jump over to our news agent in the field, Mark. Mark, what do you have for us?
Yeah, so any webinar around utilities isn't going to be complete without a little discussion around data quality, and hence our title for this webinar, Meeting the Demand for Quality Utility Data. So CAD files are often a key part of the design process. CAD to GIS data conversion, design to facilities, for example, is still one of the fundamental uses of FME, I would say. You need to ensure that that CAD data coming in, or actually any other data that comes into your organization for that matter, that you bring it in to your organization in a state of high quality. Data quality is the key to successful decision making. If you search our website and our webinars pages for presentations on data validation and data QA, you'll find a lot of discussion on the topic. As I mentioned in one of our FME World Tour presentations, technology is an amplifier or a multiplier. And if you have good quality data, then the technology you use will amplify the good decisions that you're able to make with that data. If you work with poor quality data, the technology will multiply the impact of your poor quality data and help you make more poor decisions around that bad information. One of our users said, well, actually, that was one of the US presidents, trust but verify. So the idea being that you can trust your data suppliers, but verify their data is trustworthy. Dave Ellerbeck at Global Information Systems has worked with many midstream utilities to validate their incoming data, and he's got a couple of presentations up on our web pages if you want to dig out what they've done, some really sophisticated CAD data validation. Our partner Consultech in Quebec, they've built a very robust CAD validation pattern that is easy to implement in different environments to suit your needs. Validation rules that they build for your use case are defined in an Excel spreadsheet, so they're easy to update and change with different environments. And then FME matches the source CAD data to the rules in that spreadsheet and validates the data to make sure it meets your data delivery specification. They worked with Calvin Hone at the city of Henderson to implement this process, to validate CAD file submittals that are coming in to their utility side of their organization based on the CAD standard they had put together. And so really that process involves defining that CAD standard, building a simple web interface so that people can submit their drawings, validate that submitted data using that CAD validation process, and then you can either load that data directly into your GIS if it's been validated successfully, or return it back to the data provider with a good error report that just describes where you think there were gaps in the data, and hopefully they can correct it before submitting it again. So definitely one of the key uses of FME for utilities is getting their data from external data providers and validating that data. Okay, so on to our next kind of topic that Trent and I have been working on quite a bit over the last while, and that's around data migration. And again, good old Wikipedia defines data migration quite well. It's the process of selecting, preparing, extracting, and transforming data and permanently transferring it from one computer storage system to another. I like that definition. Additionally, the validation of a migrated data for completeness and decommissioning of the legacy data storage are considered part of that migration process. So typically a one-time data operation that, although it's a one-time, actually can take quite a long time to complete because of that assessment for completeness. Maybe we can have a hands up from any of the attendees that have gone through this rather painful process. And Trent, in your view, what's the hardest step in that data migration process?
Originally, I would say writing to, or getting into the new data model, which I guess is schema mapping. Something I thought originally would be the easiest turns out to be the most difficult in terms of it's the most tedious, exacting, and time-consuming process I have ever encountered. Do not underestimate the time and resources needed for building the schema mapping from your source to your target database model. It is daunting.
Yeah, there's a lot of detail, a lot of exactness, and yeah, you need to get that right. So this year we had quite a few people talking about migration projects that they had worked on using FME. So you're building workspaces, essentially, or workflows that you are going to chuck away, but they do need to iterate as you load. Typically, when you load data into the new database, The users and the business side of the organization find that there are gaps in the data, not bringing across everything they wanted. So they change the data model slightly, and then you have to update that migration process to accommodate that. So although they are one-time throwaway workflows, they do iterate quite a bit. So one of our presentations in this year's World Tour, lift and shift 20 million features with ArcGIS data interoperability. So ArcGIS data interoperability is FME technology inside the Esri applications. And George Sherian of Magnolia River described how they migrated the 20 million water utility features between 40 different databases for American water. So that's a lot of disparate data that needed to be pulled together. The Magnolia River Services GIS team was leveraging data interop extension to automate the complex mapping between those legacy systems and an updated water network enterprise database. Trent and I here have been working quite a bit with the Esri utility network data model. We've been building workflows to help people migrate from the old ArcGIS geometric network into the Esri utility network. And that covers water, gas, and we've released some electric, and then they've updated the electric data model, so we're just about to release it for the latest electric data model. Another presentation that one of our partners did, Tenzing in the Netherlands, Tenzing International, they assisted the data migration of two large water companies in the Netherlands, Groningen and Drenthe. I probably totally butchered their names, I'm sorry. They managed their assets using a GE Small World-based solution. Both organizations decided to migrate their data assets into a common structure so that they had a more integrated data network, I guess. So they have ended up using the ArcGIS water utilities data model. And so that migration was from Small World into the Esri UN data model. In addition to the migration, the schema consolidation effort was needed because the two Small World data models were quite different. So FME was used in all aspects of that data migration and data validation of the workflows. From the beginning, when reading Small World data, evaluating and validating those data inputs, and then creating reports on data validity and automatic notifications to any of the key stakeholders about the migration process. Overall, I think that seemed like about a 9-month project, they said. And I think, Trent, we're going to switch over to working with the ERP systems. Is that right?
That is correct. So looking at ERP integration, so the city of Sandy Springs needed an integration with an enterprise permitting system called Energov by Tyler Technologies and their ArcGIS data. So they have created a workflow that pulls utility permit information every night and attaches it to their GIS data hosted in ArcGIS Online, which in turn is displayed on publicly available maps. The FME was used to perform a series of queries on SQL Server databases that underpin their permitting software. And it then configures the data and updates attribution of an ArcGIS Online hosted feature class, supplying their utility permits. Now, providing ArcGIS Pro and ArcGIS Online editing rights to the assistant utility manager, they are able to maintain their own GIS records, which would be too burdensome on current GIS staff to maintain, all while automating that attribution update and eliminating any duplicate data entry. This replaced a cumbersome process of manual exporting from the permit software, joining to the GIS, and overwriting processes, which resulted in delayed information and additional staff time. The final data is made available in a public web application of utility permits and released on the city's open data site. Now, the software involved in this project for them was their SQL Server database, as I mentioned, ArcGIS Online, ArcGIS Pro, FME, and Windows Task Scheduler. I think, yeah, there's a link in the presentation that you can see the public app in work in that little link here you see. And another example of integration was the Traverse City Light and Power, where they have automated data integration from Windmill, which is their engineering software, along with their Novatox, which is their asset and work order management, and with their OMS and their energy efficiency, which is their SEW software, and their dispatch. Now, looking at even more integration, at last year's, or this past year's FME World Tour, Hamza Sharif of Red Planet Solutions in Kuala Lumpur gave a presentation on the ongoing migration of data from a mobile data collection platform into the desktop core GIS, and on top of that, then pushing into a WebGIS platform, just to show us that, in fact, migrations don't have to be a one-time task, but can be automated and ongoing. Now, their process was migrating mobile GIS data from data collection vendors and migrating this into their core desktop GIS, which would then be pushed into their WebGIS environment. As such, rather than a one-off migration, this became a regular part of their workflow. Using FME, they were able to account for the variant data challenges, such as format conversion, pre-validation, frequency, and data manipulation. Through using a few workspaces, they were able to create a repeatable workflow, pushing their mobile GIS into their desktop core. From there, they could export into their WebGIS. As with anything to do with migration and migrating to the web environment meant new challenges had to be faced, such as daily exports, division-based in terms of, do they just want to export their distribution network, their transmission network, or their generation, as well as merging of layers. Now, at the completion of this project, they gained 100% automation on their desktop export to web. The data syncing to the web was reduced from a month to a day. That is incredible. And then the redundancy is reduced or removed entirely with pre-validation workflows being set up. And lastly, the most important part for them was the topological and network connectivity was maintained throughout the entire migration process, as opposed to breaking it apart and having to rebuild it in the desktop core, and then lastly in the WebGIS.
And we've worked with Red Planet on and off over the years, and they've actually doing other interesting things. They are looking at using machine learning for pattern recognition to see if they can identify transmission line insulator cracks and pole location identification, hoping to convince them to see if they can take the rules that they've built around that and push those through some of the new tools that we've added on machine learning in FME. So we thought we would cover a couple of ideas on FME, working with FME on the bleeding edge without actually drawing blood, sweat, and tears. To wrap up, we're going to have a couple of short examples around that, where FME is sort of being used outside of its traditional areas, let's say, and just show how it's just really imagination and creativity that's needed to solve problems that you might not typically associate with FME.
So UAVs or drones, for example, are kind of on one aspect of the bleeding edge, if you will, that FME can work with. So UAVs or drones are perfect tools for utilities to use to assess the condition of infrastructure, whether it's tree encroachment surveys or emergency response damage assessment. But there are regulatory and other hurdles that have to be overcome. Now, drones are particularly good for assessing damage during storm evaluation, where access might be limited due to fallen trees or flooding. Now, Renato Salvi-Leon from Esri has been assessing the use of FME for drone flight planning. He has been looking at how to use FME along with the new Esri utility network data for a pre-mission planning analysis. Now, drone-friendly sections of the transmission lines are determined for storm dispatchers using drone teams in their storm evaluations. Dispatchers know the safe places they can send drone teams for a damage assessment and where they need to send ground crews where an event occurs. Another aspect that has really propped up in recent years is the idea of augmented reality. Now, Jacobs has implemented this in terms of using it for their engineering consultancy and design and environmental services. Now, Jacobs looked at creating 3D underground services with FME as a way of performing clash detection between existing and potential design services. Now, when beginning this project, Jacobs had to try and account for a mix of 2D and 3D data, as well as having no real set schema. Different designers for service types, along with various software packages, meant that there was no set data source or schema that could be utilized outright. Ideally, all their data would be created in a 3D model, and clash detection would be done in a design review application. However, due to time, resource, and cost restraints, this was just not a viable solution for them. As such, they sought to combine the different data sets into a singular GIS service model. This meant for the design pipes and services, the CAD files that had annotation only and no attribution, they would be required to be associated to associate the annotation text to the line work to create smart lines, basically lines with information. Designs often display multiple lines as a single line in CAD, as the center of the trench, basically. This had to be corrected to produce an accurate model done by using information located in the text. Line work would be draped over the terrain model to get the elevation onto the lines, and then lowered by the design cover level. This allowed, they would then be able to buffer the line work as well as the radius and clearance level to create a clearance 3D object for those design pipes and services. Now, for the existing pipes and services, which is used to help further iterations of design with both existing and new designs. For the existing pipes and services, this required associating the node locations with invert depth. Now, some interpolation was required with invert depths where missing along the line. They would also rebuild lines with the new Z coordinate from node to node. Where an invert could not be established, they would drop the node to design standards. Now, from this project, the output they produced was a full 3D model of design services in various formats, such as a GIS Esri multi-patch format, IFC, and a 3D DWG. The 3D model of existing services for context and future iterations, design improvements, and new designs. A 3D clash, hard and soft in various formats, again, such as the multi-patch or the IFC or the 3D DWG. And they also had clash envelopes for 2D designer use. Now, they also generated a spreadsheet of clash types and the statistics, along with a dashboard for high-level overview of issues. In the end, just the ability to take different inputs of various types and output to various output sources for best use. And by taking isolated design services and creating a single 3D model in GIS format with the smart attribution on it to determine clash, helped them tremendously with their process.
So that's it. I'll rush through a montage of a wide range of presentations, really interesting and great presentations from many of our users. Thanks very much for joining us. Hopefully we've been able to show you examples of FME being used in areas that maybe you haven't yet thought about using FME for, yet tried, and that might fit with your organization. So maybe your call to action from this webinar might be to see if you can add one more new task for FME in your organization before the end of the year and get more value out of the FME licenses that you have and the effort that you have put into learning and understanding and using FME. You'll receive an email with a link to these slides following this webinar, and they have links to all the presentations that we've been butchering here, and my apologies to those authors of those great presentations that we did chop them up and reduce them in size so severely. But if you want to dig deeper, you can go and look at those presentations. Also, the FME 2020 user conference is coming up next year, as well as the 2020 World Tour. And so if you're using FME to solve a problem in your organization, please think about sharing it with others, because I think we all learn a lot from these different uses of FME in organizations. Don't think that it has to be some hugely complex workflow you're solving. And I would say that it's often the simplest tasks that are automated and that save you time and therefore some money that make the most interesting and compelling presentations. So you don't really have to feel that you're an FME guru to make a simple presentation at one of our events, and we'd really encourage you to do that. And with that, thank you very much for attending, and it's goodbye from me, and
Goodbye from me.
and thanks very much for joining us. Bye.